All right, so rules for radicals, which should not be brand new, but you can never leave a radical in the denominator. It's against law, against the math law. And you can never leave a fraction under a radical sign. Okay, so we've got 3 examples here. Is this all right? Can we leave it like this? Yes. You can have a radical in the numerator, not in the denominator. So when we get to this one is a no, right? Because we got a square root down there. And this is a no because we have a fraction under a square root. Okay, so we have ways of fixing those things. So one thing we can do is to rationalize the denominator. But before we do that, we can look at the 2 different forms in example 1 and example 2. This is a square root over a square root. This is a fraction under a square root. These really do the same thing. So if I have it like this, I can rewrite it as 27 over 3 like this. And what's 27 divided by 3? 9. So that's the square root of 9, which is 3. Okay. And then in example 2, I do not have, or I can't reduce that fraction, right? But I can make that into the square root of 2 over the square root of 9. So I went from, we can't leave a fraction underneath there, to having 2 different square roots like this one right here. But now, square root of 2 is just the square root of 2, but what's the square root of 9? 3. And then I'm fine. I didn't have to do anything fancy. I was basically just simplifying that a little bit. If you end up with a square root in the denominator that is not a perfect square, then you have to rationalize the denominator. Whatever the square root is in the denominator, in this case the square root of 6, you multiply it by a fraction of the square root of 6 over the square root of 6. Because that green fraction I just wrote has a value of 1, right? So I'm not changing the value, I'm just changing the way it looks. I just multiply straight across and get 2 times the square root of 6. What's the square root of 6 times the square root of 6? 6. Okay? I cannot reduce these 6's because one's inside, one's outside. They live in 2 different worlds. But I can reduce the 2 and the 6. And 2 over 6 reduces to 1 over 3. So this is really just the square root of 6 over 3. Okay. All that sound familiar? So none of that's brand new stuff. All right. So then in number 4, same type of thing, but I don't have to multiply by the entire denominator. I only have to multiply by the square root part. So I have to multiply this by the square root of 5 over the square root of 5. The 2 that's being multiplied down in there, he's fine. So, I mean, I could multiply it by that, but then I'm just making my life harder, so don't want to do that. When I multiply a whole number times the square root, they just get stuck together, like so. Then I have this 2 times, and then the square root of 5 times the square root of 5 is 5. So this is 13 times the square root of 5 over 10. And then I cannot reduce the whole numbers that are on the outside. They don't reduce, and then 5 and 10, that wouldn't be legal anyway. Everybody good with all that stuff, right? Okie dokie. So then let's look at example 5 here. So the first thing I want to do is make this into one fraction, or I'm sorry, one square root. You get 24x to the 10th over 6x to the 4th. All right, so 24 divided by 6 is what? 4. And x to the 10th divided by x to the 4th is? X to the 6th, good. And then, square root of 4 is 2. What is the square root of x to the 6th? X to the 3rd. You just take the 6 divided by whatever the index here is, which is basically 2, so it's x cubed. That's it. Okay. Now, in example 6, do you think we could reduce the square root of 24? I think we probably can. But even if you can, you don't have to at the beginning. I mean, it's kind of a, preference, whichever way you'd prefer to do it. But it's fine to just say, okay, I'm just going to go ahead and rationalize this. because even though that's a bigger number, it doesn't make anything any more difficult. So this gives me 8 times the square root of 24 over 24. Then can I reduce that? Does 8 go into 24? How many times? 3. So this gives me the square root of 24 over 3. We agree with that? Now that I've got that and reduced that, then I can worry about the square root of 24 and simplifying that. What are two numbers that multiply to give me 24? 12 and 2. What are two numbers that multiply to give me 12? Okay, 6 and 2. And then 6 would be 2 and 3. So then what can I reduce the square root of 24 to? Good. 2 times the square root of 6, because these two come out as a regular 2. These have to stay underneath, and we multiply them back. So that means I get 2 times the square root of 6 over 3. Can I reduce that anymore? Nope, that's it. Okay. So you get the same answer whether you simplified it at the beginning or at the end. Doesn't really matter. Everybody okay with all that? All right. So now let's talk about conjugates. Okay. Two binomials that have the same terms but opposite signs between the terms are conjugate pairs. So we got a plus the square root of b and a minus the square root of b, or a plus bi and a minus bi. Those are conjugates. You change the sign in between them, and that's the only thing you change. So if I have 3 plus the square root of 2, my conjugate is 3 minus the square root of 2. If I have 1 minus the square root of 3, then the conjugate is 1 plus the square root of 3. Okay? We need conjugates because you can't leave a radical in the denominator, and sometimes we have more than one term. And when you multiply conjugates, you're going to eliminate the radicals. And here's what happens. If I have, let's just multiply these two together right here. So a plus b, or a plus the square root of b, times a minus the square root of b. So to FOIL them, I multiply the first two together. A times a is a squared. The outside two together, so that'd be minus a times the square root of b. Inside 2 plus a times the square root of b. And then the last two, positive times a negative is a negative. What's the square root of b times the square root of b? B. These two zero out, so I end up with a squared minus b. That's just a difference of squares. If you'd have looked at it a little differently, like if I'd have just said, if I have, I don't know, x plus 2 times x minus 2, you wouldn't have to go through all that, right? That's a difference of squares, so we know we square the first one, x squared, and then minus, and we square the second one, and we get 4. So see, you square the first one, minus, square the second one, there's your answer. So when it says find the product of 5 minus the square root of 2 and its conjugate, that means I'm going to multiply 5 minus the square root of 2 times 5 what? Plus the square root of 2. And when you do that, because it's a difference of squares, you don't have to go through all these steps every time. You square the first one, 5 squared is 25, minus, and what's the square root of 2 squared? 2, and you end up with 23. Okay, so you're just applying the difference of squares, basically. Everybody okay with that? How conjugates work? So let's do a couple of these then. I need to rationalize the denominator. I cannot just multiply by the square root of 3 because I'd have to distribute it down here. So I have to multiply by the conjugate, which would be 2 minus the square root of 3 over 2 minus the square root of 3. And then everything that has more than one term on it really should have parentheses, so we remember to do all this stuff correctly. I need to distribute this 6 in here. So 6 times 2 is 18, minus 6 times the square root of 3 over, and then I square the first one, which is 4, minus, I square the square root of 3 and get what? 3. So really, 4 minus 3 is just 1. Yes, so I get 18 minus 6 times the square root of 3. It is 12. Oh my God. Thank you. Y'all took that long to stop me? I just looked at my answers and I was like, wait, where did I get that from? It's 12. 6 times 2 is 12. It is not 18. Good Lord. There we go. And then can I actually combine those terms? I cannot. That's like 12 minus 6x. Okay? What questions do you have other than why can't I multiply? We good? All right, good deal. All right, so then what am I going to multiply this one by? 3 what? Plus the square root of 2 over 3 plus the square root of 2. Put my parentheses around this stuff so I don't forget to distribute things. And let's see if I can distribute them correctly this time. When I distribute here, square root of 6 times 3 is just 3 square roots of 6. Plus, and then the square root of 6 times the square root of 2, you can multiply everything underneath together, so that becomes the square root of 12 over, then I square the first one and get 3, minus square the square root of 2 and get 2. So in the denominator, once again, I'm going to get 1. But can I simplify the square root of 12? Yes. 2 numbers that multiply to give me the square root of 12, 4 and 3. Now, we can keep going and do the whole tree, which is not a bad idea, but on ones that come up a lot, like the square root of 12, the square root of 20, the square root of 8, that you just kind of learn them, you can take the square root of 4 right there. That's just going to give you 2 square roots of 3. So that means this gives me 3 square root of 6 plus 2 square roots of 3. And then can I combine those? Oh my God, it is 9. What is wrong with I told y'all I should have stayed home today. I just checked my answer. I was like, what? Where did I get that? I must have done my key wrong. No, I didn't. What should this be? 9. So I don't get 1 in the denominator. I get 7. Thank you. Here's the good news. The things I mess up on are multiplying. I'm not teaching you the material wrong. I just can't multiply. And I can't. I got different cold medicine at lunch that works better, but I think it's also making me a little foggier. So, all right. Any other questions besides the same question, which is why can't I multiply, okay. Or why can't I square numbers? All right. Let's see how I do with this one. So I need to now. Both the numerator and denominator can be rationalized. There are times in math where sometimes we rationalize the numerator, but those are like specific cases that you would know if that's what you're trying to do. So our goal is to rationalize the denominator. So we're going to multiply by 4 plus the square root of 10. 4 plus the square root of 10. Okay, put parentheses around all this stuff. So in the numerator, this is a special case, but it's not necessarily one we always remember. So probably most of us would just FOIL this anyway. So we multiply the first 2 together. 4 times 4 is 16. Stop me sooner if I do something stupid. The outside 2 is going to be plus 4 square roots of 10. The inside 2 would be plus 4 square roots of 10. And then the last 2, square root of 10 times the square root of 10 is 10. Over, then we square the first one and we get 16 minus the square root of 10 squared, which is 10. So we all agree now with this one before we go any farther. All right, so then in the numerator, this 16 and the 10 I can add together and get 26. 4 square roots of 10 and 4 square roots of 10 give me 8 square roots of 10 over 6. Now what I really should do to do this correctly is to factor out a GCF in the numerator. You don't have to as long as you don't make up math. Okay, I have 2 terms in the numerator. If I'm going to reduce this fraction, I can't just reduce the 26 and the 6. Okay, all 3 of these terms here would have to be divisible. All 3 of these numbers would have to be divisible by the same number. So what are all 3 of those divisible by? 2. So if I divide them all by 2, that's going to give me 13 plus 4 square roots of 10 over 3. What questions do you have? Anything at all? Okay. Now on 10, the denominator is irrational because I represents the square root of negative 1, right? So even though you don't physically see a square root down there, there's a square root down there. So the conjugate for this one, all I do is change the sign in between. So this is going to be negative 3 plus 7i over negative 3 plus 7i. Okay, don't change both signs or anything like that. I'm going to put parentheses around everything so that I can multiply. So in the numerator, I'm going to FOIL. First is 4 times a negative 3, that's a negative 12. Outside 2, 7i times 4 is a positive 28i. And then negative 10i times negative 3 is a positive 30i. And then negative 10i plus, times a positive 7i is going to be a positive 70i squared. Okay, everybody with me so far? Then the denominator, we do the square of the first one. Negative 3 squared is a positive 9 minus 7i squared is going to be 49i squared. Any questions at this point? All right. What is I squared? Negative 1, right? So doesn't this right here really just become a negative 70? Because I have positive 70 times I squared. I squared is a negative 1, so that's a minus 70 right there. Which means this negative 49i squared, if negative 49 times negative 1, this is really just a plus 49. You agree with that? Okay. So then when I combine them all together here, I'm going to have negative 12 and negative 70. It's a negative 82. Yes? Okay. Second guessing myself here because I thought this worked out differently. Plus, I trust nothing anymore. What did I do? Did I do something wrong? Dang it! Yes! God, y'all. Okay. I do. I need to. Maybe we should. I need a nap. I need something. Here, I'm going to erase all of this. I'm going to start back over here. I don't want to. I'm probably confusing y'all more than I'm helping y'all at this point. I just can't multiply. It's like I don't know. I blame the cold medicine. Okay. Let's FOIL the numerator again. Well, the numerator was fine, wasn't it? No, it wasn't. Never mind. Positive 4 times a negative 3 is a negative 12. Do we all agree with that? Okay. Outside 2. Positive 4, positive 7i, positive 28i. Yes? Yes. Negative 10i, negative 3, positive 30i. Yes? Negative 10 times positive 7 is a negative 70i squared. I had the sign wrong. I had the number right that time. But it doesn't really matter because it was still wrong. Then I squared this. This is a positive 9 minus 49i squared. Okay. Do we all agree at this point? Yes, I hope so. Good Lord, are we almost done? I hope so. So we decided that I squared is negative 1. So this actually becomes a plus 70, right? And this becomes a plus 49. Does everybody understand where those came from? Okay, good. So now, negative 12 and a positive 70, when I combine those, that gives me a positive 58 plus 58i. Oh. Say that again. Wait, what's the question? I didn't multiply, I was adding. I was adding. Negative 12, I don't know what I said, but what I was doing was adding negative 12 and a positive 70 is a positive 58. And then I added the 28i and the 30i, and I got 58i. Then I have 9 plus 49, which is a positive 58. Yes? Okay. So then, all three of these numbers have to be divisible. What are all three of those divisible by? 58. Now, don't do weird things when like the numbers go completely away. I have no zeros anywhere, right? This becomes a 1 plus what? I. And that's my answer. Careful with the zeros there, because they're not zeroing out. That was painful. And you know what? No, I'm going to go ahead. I can do this. I was just like, I really don't want to make things worse on the next ones because I got to explain a little bit more. I got this. All right, I can do this. All right, so let's look at example 11. Can I reduce that first? What can I reduce both of these numbers by? 3. Okay, so then this becomes the square root of 9 over the square root of 2x. Because I divided them both by 3. Do we agree with that? All right. What is the square root of 9? 3. So this is just 3 over the square root of 2x. Can I leave it like that? No. I multiply by the square root of 2x over the square root of 2x. In the numerator, I multiply straight across, get 3 times the square root of 2x. In the denominator, I get 2x, and I'm done. Okay, what questions do you have? Okay, now let's talk about why we are multiplying by the same thing here. Because the index that we can't see is a 2, right? The index here is a 3. So basically to make the root go away, I'd have to have 3 of the same things multiplied together if it was a cube root, 4 of the same things if it was the 4th root. So in order for me in the denominator, what I need to get on example 12 is the cube root of the quantity of 4x cubed. And if I have that, then they cancel each other out. Does that make sense to you? In the denominator here, when I multiply by something, it's going to have to be the cube root of whatever is in here to the second power. This exponent has to be 1 less than this one, because if I multiply those together, and we're going to do one extra step here so that it makes sense why we're doing this. This is the cube root, and then this has to be a value of 1. Okay? So when I multiply straight across, here's what happens. I get 4 times the cube root of 4x quantity squared. Okay, does that make sense in the numerator? In the denominator, I get the cube root of 4x cubed because I'm multiplying what's inside. So since what's inside is cubed and I want to take the cube root, that's what's going to make the root go away. You with me on that? And if I had just done the cube root of 4x, I wouldn't be able to make it go away. Okay? If I hadn't put a squared here, then this would be squared right here, and I couldn't get rid of my root. Basically, I'd have to like do it again and do it again. It's always going to be 1 less. That's why here, even though we don't put it, like your index is 2, right? And so we're multiplying by this to the first power, which is 1 less than the index. We just don't have to put all of that because it just works out that way. So then that means that here, when I simplify this a little bit, I'm going to get 4 times the cube root of 16x squared over 4x. Can I reduce this some more? And cancel those 4's out, right? So then that gives me the cube root of 16x squared over x. And just like what we would have to do on anything else, we need to see if we can simplify that root. I'm going to come over here and do the cube root of 16x squared. Well, I know I can't do anything with the x squared, but I put it there so I wouldn't forget that it exists. But then I'm going to look at 16, that's 2 times 8 and then 8 is 2 times 4, and then 4 is 2 times 2. We all agree with that? So then when I go to simplify that, this was a cube root, so I have to look for groups of what? 3. So there's 3 2's I can mark out. That comes out as a regular 2 times the cube root of, this one stays inside with the x squared, and I have an x down here. What questions do you have? Ask me a question. All right. Checking my answers over here. That's what I got when I did this when I wasn't on cold medicine, so I think I'm right. So here, we're going to multiply by the 4th root of what? 9x to the what power? 3rd. It's always 1 less than the index. So this is going to be the 4th root of 9x, and don't forget your parentheses there, cubed. Okay? So when I do that, we can skip this step right here if we want to, just like because we weren't really writing it on the other ones. Because this is squared and that's not, then we can jump from here to the root is just gone, and that's totally fine. Okay, so then this is going to give me 9 times the 4th root of 9 cubed x cubed. And I'm going to leave it like that for a minute because I'm going to show you why we can reduce this and we don't have to actually know what 9 cubed is, and it's fine. All over 9x. Everybody with me so far? Now these 9's will cancel out, but I need to simplify this root again. So I have the 4th root of 9 cubed x cubed. And the x cubed, I can tell you I can't divide it by 4, so I can leave that. But I need the factors of 9 cubed. Guess what? They're 9 times 9 times 9. See how that works? So it doesn't really matter what 9 cubed is because it's 9. I'm breaking it back up anyway. And then I need to break these each into 3's. Then this is going to give me, I guess I can write it down here. This is a 4th root, so I need how many 3's to come out? 4. 1, 2, 3, 4. Those get to come out as a regular 3. Then I have the 4th root. There's 2 3's left inside that I multiply back together. 9x cubed all over x. Okay, we good on that? What questions you got? All right, so this last one, we're going to rationalize this denominator. And so that means I'm going to multiply by the conjugate, which means I just change the sign in between the denominator there. So square root of 10 plus the square root of 6, square root of 10 plus the square root of 6. Okay. Which looks horrible, but it's really not that bad. We're going to put parentheses around all this so we remember to distribute and not do anything weird. So in the numerator, I got a FOIL. Multiply the first 2 together, that's the square root of 30. Outside 2 together, that is the square root plus the square root of 18. Right. Inside 2 together, minus the square root of 50. Last 2 together, minus the square root of 30. Okay. The denominator, that's a difference of squares, so I can square the square root of 10 and get 10, minus square the square root of 6 and get 6. Then I got to clean up the numerator. Do you see something that worked out kind of nicely in the numerator? Believe it or not, like this is a question I just made up, and I was like, let me see what happens when I multiply, and it worked out real nicely because square root of 30 and negative square root of 30, those just zero out. Okay? But then square root of 18 and square root of 50, I do need to simplify both of those. So square root of 18 What are two numbers that multiply to give me 18? 6 and 3. And then 6 can be 2 and 3. So that means square root of 18 is 3 square roots of 2. Yes? Square root of 50. Isn't this 25 times 2? What's the square root of 25? 5, so 5 square roots of 2. So that means what I have here is the square root of 18 was 3 square root of 2 minus the square root of 50, which is 5 square roots of 2 over 4. Can I combine the numerator? Yes. Sometimes you can't, just so you know. You may end up with something where you have two terms in the numerator and you can't, but in this case you can. This is going to become negative 2 square root of 2 over 4. Can I reduce that some more? And it's negative square root of 2 over 2. Okay. Everybody good so far? Okay. Any questions at all? Awesome. Good, because I think I'm definitely done for today.